And if you overdraft, they charge you.
Wait, I thought it can get overdraft protection. Okay, that's what I thought. That's what I'm going to get, because I thought I would get overdraft. You know, I don't do overdraft protection on mine.
Okay. On the first one here, we're looking at our study guide. First one was a pretty simple one. I got aggravated yesterday at people that they look at number one, well, I don't know what to do, and they didn't even try to draw the graph. All of this stuff, quadratics, relate to a parabola graph. When in doubt, draw a picture. Okay, it becomes a little bit clearer to you on those when you do that. So what it tells us about this on number one is that we've got an axis of symmetry at x equals -2. So from the origin, if I go x equals -2, I'm right there. So I've got an axis of symmetry. Let's just use this. I've got an axis of symmetry there. Preferably a straight one. Okay? Then it tells me that the point -5, 6 is on my parabola. Well, there's -2, so -3, -4, -5, and then up to 6. So that would be on the parabola. Okay? Now, people were like, well, how do I find the vertex? You don't need to find the vertex. It wants to know what would another point on the parabola be. Remember that axis of symmetry cuts it in half. It's the reflection line. So very good. I look and I say, well, that's 1, 2, 3 away. So I'm going to go 1, 2, 3 away on the other side. If I was at -2 and I moved 3 over, where am I at now? 1, 2's at the origin, 3 would be at 1. So I would have another point at 1, 6. Okay, that's just a common sense counting problem there.
What made you move 3? That's fine.
Because from -5 to -2, it moved 3. 1, 2, 3.
I got you now.
Okay, very good. Number 2 and 3, both we're doing the transformations. We've been doing them since the beginning of the school year, so we ought to be able to get 2 and 3 both pretty good by now. Number 2, it gives you f of x is equal to x squared minus 3. Wants us to write a rule for g, so we're going to have g of x equals something. All right, it says a vertical stretch by a factor of 4 and a reflection on the x-axis. Reflection x-axis and vertical stretch, those just both go out in front. So I'm going to have my reflection and a vertical stretch of 4 out in front of that whole thing. Okay? If you wrote that as your answer, that's correct. But that would also be correct, wouldn't it?
Yeah.
So either one of those would be a good answer for number 2. I'd take either one. Give you a high five on either one. Okay. 3's the same type of deal. It gives us f of x is equal to the absolute value of x minus 4 plus 2. Wants us to write a rule for g, so we're going to have g of x equals something. It says we're going to translate it 1 unit down. Up and down is what's stuck on the end. Down means minus, so I'm going to take 1 off of what's stuck on the end. Then it also says I'm going to go 3 units to the left. Left and right is in with the x. You go the opposite. Normally left means minus, but that means I'm going to add, so I'm going to add 3 there. So it's going to get me absolute value of x minus 1.
So is that our answer?
Plus 1. Because the -2 plus 1 would be 1. So that would be our final answer there.
So if it goes down, it goes on the end.
Yes, up and down, stuck on the end. Yes, sir.
And then left to right is inside.
In with the x. Yep. All right, number 4 is like off of the assignment that you had the other night, off of the back side, the Yellowstone Park side. It says f of x is equal to 1 over 16x squared. We're asked to identify the focus, the directrix, and the axis of symmetry. Okay, so I'm going to do this the same way. Remember, this comes from the original equation of y equals 1 over 4p x squared. If I can solve for p, that's going to tell me what my directrix and my focus are. So I'm going to take 1/16 and I'm going to set that equal to 1 over 4p, and I'm going to solve. So 1 over 16 equals 1 over 4p. Now we've got a proportion, so we're just going to cross multiply. 1 times 4p is 4p. 16 times 1 is 16. So we know our p has to be 4. Now all we got to figure out is where does that belong in our answers. This f of x is the same as y, so this is a y equals, so that means my p in the focus ordered pair is the y. So I'm going to have 0, 4, right? Directrix, this is y equals, so I'm going to be y equals, and directrix is the opposite of p. Remember that? You've got notes on this. That picture that I put on there and you copied down, directrix is the opposite of p, so it would be -4. And then the axis of symmetry, it told you that the axis of symmetry on these was always going to be at x equals 0. So that question, if you have one like that on the test tomorrow, that question's worth 3 points because you had all 3 of those answers.
Can you give me a second?
Yeah. Yeah. No, he's still on the scooter, but he brings crutches around also. I don't know why. Maybe like to get in the bathroom stall or something. I don't know. Sorry, we were going to put streamers and a bike horn on a scooter.
What was that paper that we turned in yesterday called?
Quadratics or Parabola is one of those. I don't remember what I named it in there. Alright, number 5. I'm going to look at the table they gave us on number 5 real quick. It's got a 1, 2, 3, 4, and 5 on the x's. Then on the y's, we've got a -2, a 2, bless you, a 10, a 22, and a 38. Alright, it says explain why a quadratic function models this data, then use a linear system to find it. This problem takes a while. We did these in class the day we learned how to write quadratics. If we were given a vertex, we used vertex form. If we were given intercepts, we used intercept form. If we were given a table, we had to use standard form, which meant a systems of equations, 3 equations and 3 variables. Excuse me. So these are the ones that took a while. But the first part of the question says we've got to explain why this is quadratic. And that's based on the differences in your y's. Okay? So you could subtract these. You could say -2 minus 2, or you could say 2 minus -2. Sometimes you got to try both if they don't work. Okay? But I think this one goes 2 minus -2 will be the way we want to look at this to save us some time. And then 10 minus 2, and then 22 minus 10, and then 38 minus 22. All those right? Now that tells me they're not linear because I didn't get a common difference. 4, 8, 12, 16, that's not the same. They got to all be 4s or all the same number to be linear. Now we got to go to the second row. This is what will tell us if they're quadratic. If my second level is all the same, it's going to be quadratic. 8 minus 4 is 4. 12 minus 8 is 4. 16 minus 12 is 4. So for my first answer, when it said, explain why the quadratic function models this, we would say because the second level of differences is the same.
So that's quadratic.
Yes.
What is the first level?
That'll tell you if it's linear.
And then third would be
Cubic, but we haven't gotten that far yet. Alright, but we're not done with this good old number 5. Now comes the hard part. We got to use a linear system to find the model. That means to write the equation. Okay, so everybody got what you need on that page so I can get a new sheet going? Good. Alright, so we're looking at y equals ax squared plus bx plus c. So the first thing you have to do on this is pick the points you're going to use. So I just stayed simple. I'm going to use the 1, -2 the first time. Then I'm going to use the 2, 2 the second time. I'm doing the first 3. Then the 3, 10 the second time. Remember, those are x's and y's, so that I'm going to plug in for the x's and the y's up here. So my first one says y equals, so -2 equals a times x squared. My x is 1. 1 squared is 1, so that's 1a. B times 1 is 1b. And then I don't know anything about my c. Okay? I'm done with that one, so now I'm going to go to the 2, 2. Y equals, so 2 equals x squared. 2 squared is 4, so that makes a 4a bx. B times 2 is 2b plus c. Now I'm going to the 3, 10. So y equals 10 equals ax squared. 3 squared is 9, so 9a. 3 times b plus c. When we did most of these in class, I wrote the equal stuff on the other side. So if you wrote it a plus b plus c equals -2, that's okay. That's how we normally write them. Alright, now I'm looking to eliminate a variable. The c's all have 1s, so it's going to be easiest to eliminate the c's first. So what I'm going to do here is I'm going to subtract the first 2 equations to eliminate the c's. Okay, so I got -2 minus 2, that's -4. A minus 4a. B minus 2b. And c minus c is gone. Okay, now I got to get another new equation with no c's, so I'm going to subtract the second and the third one to eliminate those c's. 2 minus 10. 4a minus 9a. 2b minus 3b. And my c's are gone. Alright, so now I've got 2 new equations there, and the b's both have a -1, so they're ready to eliminate. They're both a negative, so same sign, so I'm going to subtract again. -4 minus -8 is 4. -3a minus -5a is 2a. -b minus -b is gone. So I can solve this for a now. We got an a of 2. Okay, now I got to take that a back to one of my new ones and plug it in to solve for b. You want to do the first one or the second one? Where my mouse is? First one. So I got -4 equals -3 times 2 minus b. So that's -4 equals -6 minus b. Add 6. 2 equals -b. Divide by -1. And my b is -2. We're missing a c, so we got to take our a and b back to one of our original ones to find the c. Is the first one all right with everybody, since it's just ones up there? We got -2 equals a plus b plus c. 2 minus 2 is 0, right? 2 plus -2 is 0, so I just got -2 equals c. Okay, we were supposed to be writing a function for this parabola that this would make, so we've got an a, b, and c. We just got to plug that back in our standard form. So that's going to be f of x or y, whatever you want to use there, equals ax squared plus bx plus c. So that would be your second answer for number 5. Luckily, there was only one of those.
I thought we got, so you just took our numbers and plugged it into that.
Yeah, into standard form. Yeah.
You don't, would you count it right if we just put those 3 numbers?
I may, probably, but if saw it on ACT or something. You have to
It
write
says
the
put the
equation.
standard form,
It's said to write
then use a linear system to find the model.
the model. The model means the equation. All right, okay? 6, 7, and 8, and 9, we're all writing an equation for the parabola, so what we have to do is use what we know, use what they gave us to know which way to start. Because I sure don't want to have to do that way again, right? So we're going to take shortcuts and use what they gave us on these. All right, so on number 6, they gave us a focus and a focus and a vertex. Anytime I see focus or directrix, I know I'm going to be looking at the 1/4p stuff. Okay, focus and directrix takes me to the 1/4p stuff. So that's what I'm looking at on these. On 6, 7's a little bit different because 7's a sideways one, but it's still going to be the 1/4p stuff. All right, so the focus on number 6, you got to look there and count. It's up over 0, up 1, 2, 3, right? Everybody see that on number 6? It's got a focus of 0, 3. And remember, the focus is 0p. So we know our p is 3. So I just got to plug a 3 in there. So I'm going to have y equals 1/4 times 3 x squared. So that's 1/12 x squared. And that's all you would have to do on that.
So the focus is 0p.
Yes?
So what you do is you take
We had to count up there and see what our focus was.
Wait, where did you get 4 from?
It's always 1/4.
I thought it was 1/2.
It's always 1/4.
Is there anything else to do that's always 1/2?
Not that I remember, no. All right, 7. 7 sideways. So when the parabola is sideways, instead of y equals, it's going to be x equals. So it's going to be x equals 1/4p times y squared. Okay, this time they gave us the directrix on number 7. So I count to the directrix and it's at 3. X equals 3. Now the directrix, remember, is the opposite of p. So my p is going to be -3 on this one. So I'm going to have x equals 1/4 times -3 y squared. Go ahead, Trevor.
how you know your directrix is -3.
I counted to where that line is on the graph. Start at the origin, and it's positive 3. You move to the right 3 to get to it.
Yeah.
But then the
1,
p,
2.
now start, look where the origin's this one. See, because there's your line. So start from there, 1, 2, 3. And then your p is always the opposite. Since it's positive 3, my p is -3. So we'll finish that out. That'll be -1/12 y squared. That's it. All right, 8, they gave us different stuff. So our plan of attack is going to be a little bit different on number 8. They gave you a random point on 0, 3. So let's make some notes of what we got. We got a random point on 0, 3. They gave us an x-intercept at -2, 0, and another x-intercept at 6, 0. Everybody see those points on that graph? They gave me the intercepts. Intercept form is a times x minus p times x minus q. -2 and 6 are what you're plugging in the p's and the q spot. Now you got to do the opposite sign on them. So it's going to be y equals a times x plus 2 times x minus 6. You can't leave it there though. Remember when we did these in class, we had to solve for a? That's why they gave you another random point. So you can plug that in the y's and the x's and solve for a. So 0 will go in for the x's and 3 will go in for the y. 3 equals a times 0 plus 2 times 0 minus 6. So that's 3 equals a. 2 times -6 is -12. I'm trying to solve for a. It's being multiplied by negative 12. So I'm going to divide by negative 12. My a would be negative 1/4. Okay, so now all you have to do is take that a
Plug it in.
back to here and just write your equation like Trevor said. Y equals negative 1/4 times x plus 2 times x minus 6. And that's it. You could take it farther like Stephen was doing on the bell work and get it into standard form or get it into vertex form, but you don't have to. Save yourself some time and you're good there.
Will you tell me where all three of them equations came from?
This one is called Intercept Form. Is this what you mean?
Yeah, like why we got three of them.
Well, that's the blank one. That's what Intercept Form looks like. Then this one I got because I plugged over here. This is my P and this is my Q, my intercepts. So I plugged those in the P and the Q. Then this one I got when I plugged in the other random point they gave me, the 3 and the 0. Do you see where I got these 3 points from, maybe?
Yeah.
Okay. Yeah. So I just started substituting in. All right, look at number 9. What info did they give you on number 9? It's not a focus or directrix. It's not an intercept. What part of the parabola did they identify on number 9? They got 2 dots on there. One of those dots is something prominent.
The vertex?
Very good. The vertex of that parabola is at 2, 2, right?
Yep.
And so we're going to use vertex form. Now this is a sideways one. So it's going to be x equals a times y minus h squared plus k. But there's your h and your k. So I got x equals a times y minus 2 squared plus 2. But now I got to find the a. Just like we did on the other problem. Did they give you another point to use to find the a? Yeah, don't they have a dot at over 3 up 3?
Yep.
So I'm going to say 3 equals a times 3 minus 2 squared plus 2. 3 minus 2 is 1. 1 squared is 1. So that's just 1a plus 2. Which means your a is 1. So x equals, you can put a 1 here, right? But you don't have to.
Yeah.
So put the 1 or don't, either one. That's your answer. Alright, on 10, directions say identify the focus, directrix, axis of symmetry, and graph. Okay, everybody got what you need on that one? Okay, so the equation they give me is x equals negative 1/2 y squared. Before I even start graphing this, I know that since it says x equals, it's going to be sideways. And I know that since it's a negative out in front, it's going to point to the left. So I'm going to have a parabola that's doing that in a little bit. Okay, so that way I'll know to be on the right road. Alright, focus and directrix. Same thing, we're going to take negative 1/2 and set it equal to 1 over 4p. Anytime you got focus or directrix, you're going to be doing some 1 over 4p. Now I'm ready to cross multiply and solve. The question that the other classes asked yesterday is, where do I put the negative? Is it on the 1 or the 2? Doesn't matter, it can go on either one, but just make sure you only use it once. Because if you use it more than that, that negative divided by negative turns it to a positive. So I'm going to put it right here. I'm going to say negative 1 times 4p is negative 4p. 2 times 1 is 2. Divided by negative 4. So my p would be negative 1/2. And you can put negative 0.5 if you want to. Okay, so this is x equals, which means in my focus it's going to be x first. So negative 1/2, 0. My directrix is x equals, and it's the opposite of p, so the opposite of negative 1/2 is positive 1/2. My axis of symmetry on a sideways one is y equals 0. Okay, so the last thing I have to do is graph this.
Why did you change it from a negative to a positive?
The directrix is always the opposite of p.
Alright,
So when I get ready to graph this, I'm not going to be super specific, and I told some of y'all yesterday you didn't have to be either. We know that we're going to be here at the origin because they're not scooted up or down any. And we're just going to draw what it should resemble. We don't have to. We could plug some points in up here and find them, but I'm not going to stress over that.
Where'd you get the 0 from?
It's always going to be, axis symmetry is always going to be at 0.
Oh, right. Always, like no matter what?
Right. On focus and directrix, yes.
Right.
Back page, back page. Alright, we're building a bridge on number 11, the suspension bridge. Suspension bridge, it's the cables or whatever they're using to suspend the bridge that makes the parabola, okay? So you would have like your bridge here, and then you would have some kind of anchor on both ends, and you would have cables that are coming down like that. So you see that shape up there is, my drawing's bad, but that shape up there is what makes the parabola, what's actually suspending the bridge. So it says a bridge builder plans to construct a cable suspension bridge in your town. The cables being used will form a curve modeled by that equation where x represents the length of cable used in feet. H of x represents the height. At what height will the cable hang closest to the bridge deck? So what height will the cable hang closest to the bridge deck? That's a minimum, isn't it? So we're just trying to find the minimum of this vertex. So they give us 3x squared minus 6x plus 200. So I'm going to do x equals negative b over 2a. So that's 2 times 3 is 6. Negative by negative is positive, so I get x equals 1. Now I'm going to...
Negative b over 1.
2a. Let me write that again for you. X equals negative b over 2a. Now I'm going to plug that 1 back into the equation and see what that height would be. So it's 3 times 1 squared minus 6 times 1 plus 200. 1 squared is 1 times 3 is 3. 3 minus 6 is negative 3. So that's 197 feet.
Let's see what you did there.
You see, you see.
See, look, we did 2 on the bottom.
Oh, okay. Okay. You're right. And it's always 2 on that standard form equation. You're right.
Why'd you leave negative 3 plus 200 on the right there?
Well, I didn't. Negative 3 plus 200 is 197. Alright, 12, we got a graph, label vertex and axis of symmetry, and describe where we're increasing and decreasing. Everybody ready? Give me a piece of graph paper ready, Freddie.
These are pretty easy, aren't they?
Yeah, they are, especially 12 because it's in vertex form.
Yeah.
It's got f of x is equal to 3 times x plus 1 squared minus 3. Alright, like I just told Trevor, this is in vertex form, which is a times x minus h squared plus k. hk is your vertex. Opposite sign on the h. So our vertex is negative 1, negative 3. So I'm going to go left 1, down 3. So there's my vertex. Okay. So I already know, I got to label the stuff it told me. I already know my vertex.
What about line of symmetry?
I know that the axis of symmetry, or the line of symmetry, like Trevor said, is the x in that. So it's x equals negative 1. Okay, now I gotta get another point so that I can draw the graph. Okay, my A's 3, so I know this thing's gonna open up. So what about if I plug a 0 in for x? What would that give me? Let's check that out and see. 0 plus 1 is 1. 1 squared is 1. 3 times 1 is 3. 3 minus 3 is 0. So I got that point there, right? Okay, now we can just count and put our other point, because here's my axis of symmetry. That's 1 away, so I go 1 away on the other side.
My question is, what made you do the 0?
Zeros are easy to work in my head. I could have plugged in any number I wanted.
Any number.
As long as it's not the one you already got on the vertex, so you couldn't use -1 again. So you could use any other number. All right, the last thing it asks us to tell is where we're increasing. Because I already know what -1 is. That's my vertex.
-1 squared equals 1.
Uh-huh.
So how would that affect?
If I plug...
Oh, because that would be your x.
Yeah,
Okay.
yeah. All right, the increasing and decreasing thing, and you can use your notes on this. We've written this down. This is going to go decreasing first from left to right. So I'm going to write it decreases from negative infinity up to where it hits the x, so up to -1.
That's our answer.
Then it increases from -1 to infinity. Alright, said label vertex check, axis of symmetry check, increasing decreasing check, graph check. There was several points on that one and on 13 as well. Alright, 13 is in standard form. So we still got to tell all the same stuff, but our plan of attack's just a little bit different. We're going to use that negative b over 2a Chloe was reminding us about, because it's in standard form. We got g of x is equal to -2x squared minus 4x plus 3. So to start finding our axis of symmetry, it's negative b over 2a. So I'm going to have -4 over 2 times -2. Now this is kind of negative overload for my brain right here, but what I see, if I follow this, a negative divided by negative is a positive, and then a positive divided by negative is a negative. So my axis of symmetry is going to be a negative, and that's 4 divided by 4, so it's -1. So x equals -1 is my axis of symmetry. Now I got to plug -1 back in for my x, like you did on the bell ringer to find the, or that was yesterday's or something, to find the y. So I'm going to have -2 times -1 squared minus 4 times -1 plus 3. All right, -1 squared is 1, and then times -2 is -2. -4 times -1 is a positive 4. -2 plus 4 is 2, and then plus 3 is 5. So my vertex is -1, 5. One, 2, 3, 4, 5. Way up there at the top. Alright, I know since my A was -2, it's going to open down, so I'm not panicked about my graph already being up there at the top. I know it's going to open down. What I need to find now, I know, say that again, sir? I need to find another point. I know that's my axis of symmetry, so I'm going to do 0 again. Zero's my favorite because I can do it easy in my head, especially when they're on standard form. Because check this out, when it's in standard form, if you plug a 0 in, 0 times anything right here is 0. 0 times anything right here is 0. So all that will be left is your C. We talked about that on the y-intercept. Y'all remember when we talked about that? So 0, 3. So I'm over 0 at 1, 2, 3. That's 1 away from my axis of symmetry, so I go 1 away on the other side. Okay, so we're ready to draw our parabola through that. Okay, last thing we've got is the increasing and decreasing. This is going uphill first, so it's going to be increasing from negative infinity to my x, which was negative 1. And then it's going to be decreasing from negative 1 to infinity. Alright, 14 says at a recent sporting event, you notice the microphone's being used to record the sounds. The drawing of the microphone is shown. The microphone is placed 8 inches away from the reflector at the focus, it says focus, of the parabola to collect the sound. Write an equation that represents the cross-section of the parabolic reflector, assuming the vertex at the origin and the parabola opens right as shown. It said focus, so like I told you earlier, anytime you see focus or directrix, you're looking at your 1/4p stuff. Now this is a sideways one. Sideways ones are x equals, and then your y squared's there. That p, it tells you the distance that you're 8 inches. So I'm going to plug an 8 in there. So I'm going to have x equals 1/4 times 8 y squared, which is 4 times 8. X equals 1/32 y squared.
Is that all?
That's it. That one was a big old word problem that y'all didn't even try because it looked scary, and all you had to know was 4 times 8.
That's funny.
Alright, the last one, it's the company's making toy bears to sell. It's got the price of the bears and then the number of bears that they sold in thousands. So if they price the bears, like looking at your table, if they price the bears at $3 a bear, they're going to sell 84,000 of them. And then to make profits, that's what you're looking at. So it asks us to use a quadratic regression to determine how many bears the manufacturer will sell if it sells them for $9 each. Okay, all I did on this was continued the table and the pattern using common sense. So let's look in and we'll try to talk through it. What we got 3, 4, 5, 6, 7. I'm needing to go to 9. So I'm going to go ahead and add the 8 and the 9. Why 9? It said $9 for the bear. Okay? Alright. And you ought to be able to see the parabola in this as you write your y's. 84 up to 96, up to 100, back down to 96, back down to 84. So we just got to figure out what would go in here. Okay, so we got to try to see if we can see what might be happening in the pattern. We know it's quadratic, it's not linear. So what I'm looking at here, this one, let's see, can't remember, I think I went, yeah, that one would have a difference of 12. This one will be 4. This one will be negative 4. Is that one negative 12? Is that right?
Yeah.
Okay, so then these differences, negative 8, negative 8, negative 8. So that's what I've got to do is figure out what would get me a negative 8 on the next one. So something, what do you want to... Okay, I think what I'm trying to get on your page, Stephen. I'm looking for something here that's going to give me a negative 8, right? So what minus negative 12 gives me a negative 8?
Positive.
There you go, Chloe. So I need this to have a difference of negative 20. So now I got to do that again. What minus 84 equals negative 20? So what will the number be in that space? What minus 84 equals negative 20? 64. Okay? But that's not what the question asked. The question asked for 9. So we got to go again. Okay, so now I need down here what minus negative 20 equals negative 8. So x plus 20 equals negative 8. Subtract 20. Negative 28, right? Right? So now I got to take that up this level. What minus negative 28? Say that again. Uh-huh.
If you're 92. Oh, 44. Okay, then I'm wrong.
Oh wait, 28. I'll subtract 20.
So it's 92. Oh, wait, what?
No, it's 30.
It's got to be smaller.
Oh.
What am I? Y'all made me have a equals negative 8 is what I'm trying to put there, right?
Yeah.
So that's x plus 28 equals negative 8. Subtract your 28.
36.
Yes. Y'all made me.
So $9.
No. Are y'all right on that? Yes, it is 36. Yes. So if we sold, but that don't write 36 as your answer. Read the problem. If we sold the bears for $9, that 36 is in thousands. So we would sell 36,000 bears. All right. I am going to let you use any notes that you've got on paper. I will let you use the study guide if you want to. After the going over them today, do you feel a little bit better about it?
A little bit.
Good, I hope so. I hope it helps you. It is. And we try to overthink stuff sometimes instead of just being logical. Math's very logical. That's why I like it.
I like how it's